Now, can a child ever be older than their parent? If someone tells you that a child is older than their parent, you might think they're out of their mind. However, if you've watched the movie Interstellar or are familiar with the concept of special relativity, this may not sound so strange to you anymore. The root of the problem is light. For light to travel from one place to another, it needs a medium, just like ocean waves need water. In the case of light, the medium was once believed to be something called ether. This hypothetical ether was assumed to exist across the entire universe, through which light could propagate. Because light from distant stars reaches Earth, scientists theorize that something like ether must be present throughout space to enable that transmission. This ether theory was widely accepted throughout the 19th century. However, in 1887, two scientists, Albert Michelson and Edward Morley, attempted to experimentally detect the presence of ether. They designed a device where light from a single source was split into two beams traveling in perpendicular directions. These beams would then reflect back and meet at a detector. One beam would travel parallel to Earth's rotation, and the other beam would travel perpendicular to it. If ether existed, the beam traveling along Earth's rotation would be affected by the ether wind, reaching the detector either faster or slower than the perpendicular beam. Surprisingly, the experiment detected no difference in the speed of light between the two directions, completely contradicting the ether theory. At the time, there was no alternate explanation for this behavior. Then, in 1905, Albert Einstein introduced special relativity, which revolutionized physics. Special relativity is based on two fundamental postulates. The laws of physics are the same in all inertial frames of reference. That is, no matter how fast you're moving, the laws of physics do not change. The speed of light is constant for all observers, regardless of their motion or the motion of the light source. This speed is approximately 300,000 kilometers per second. This second point is particularly strange and unintuitive. Imagine you're on a moving train and you throw a tennis ball forward. For someone on the ground, the ball's speed would be the speed of the train plus the speed of the ball. That's how everyday speeds work. They add up. But light behaves differently. No matter how fast you're moving, you will always measure the speed of light as exactly 300,000 kilometers per second. This is where special relativity breaks away from our everyday experience. Let's say a person is standing inside a spaceship holding two flashlights, one pointing forward and the other pointing backward. When they turn on both lights from their perspective, inside the spaceship, both beams will travel at the same speed in opposite directions. Now imagine someone watching this spaceship from Earth, and the spaceship is moving forward at a very high speed. According to the Earth observer, the light beam moving forward should be going faster, since the spaceship is already moving in that direction. And the beam going backward should be going slower, but this would violate the constant speed of light principle. To preserve this constant speed, something bizarre happens. Time itself slows down for the moving observer. This time dilation effect has been experimentally confirmed. When the plane returned, the clock on the plane showed slightly less elapsed time than the one on Earth. The difference was tiny, but it was real, proving that moving objects experience time more slowly. So time is not absolute, it's relative and depends on your speed and gravitational environment. This concept, called space-time curvature, is central to Einstein's general relativity, which further shows that massive objects like planets and stars curve space-time around them, altering the flow of time. This is exactly what happens in Interstellar. Cooper leaves his daughter Murph on Earth and travels through space. Due to a strong gravitational field on a particular planet, time flows much slower there compared to Earth. Spending just 1 hour on that planet equals 7 years on Earth. As a result, when Cooper returns to Earth, his daughter Murph is much older than him. This was today's explanation of special relativity from the science sphere. Hopefully I managed to explain it clearly. If you want to understand it even better, you can check out the full video. If you enjoyed this, feel free to join and stay connected with the science sphere.